Welcome back to All This Math. This is Professor Parker. Please make sure you subscribe to the All This Math YouTube channel. Drop a comment below, like the video, share the video with some people. All right. Now, what are we doing today? What we're doing today is we are going to solve a linear equation, right? We're going to solve this linear equation right here. 3x minus 2 is equal to -8. But we're going to do it in a kind of what I consider an unorthodox type of way. We're going to use graphing, right? Some people call this graphing method the intersection method. I like to call it the divide and conquer method because what we do is we divide this equation up into two separate expressions, and then we make each of those expressions into their own equation. All right. So we divide the equation, the original equation, right? And then we break it down, we conquer it, you know what I'm saying? We solve it by setting up two separate equations and then graphing each of those equations, graphing the lines that represent those equations. And then we look for the intersection point or the point where the two lines cross each other. And that's why some people call it the intersection method, you know? But I like to be a little more political with my terminology when I'm doing mathematics. All right, so at any rate, let's get into it. So you take each expression, right, on each side of the equal sign. So it's two sides to the equal sign, the left side and the right side. So we're going to have y equals 3x minus 2. That's this expression over here. And then we're going to have this expression over here. A number, an integer, can be an expression too, right? So we're going to have y equals -8. All right, so those are our two equations. So we're going to graph them, right? We're going to graph them. All right, now this one, let's graph this one first. This is already in slope-intercept form, right? Y equals mx plus b, right? Already slope-intercept form. So that's cool. So what we do is we look for the y-intercept first. The y-intercept is -2, the number at the end, the number that stands alone at the end. That's -2. So we go to our graph. We look for the y-axis. The y-axis is our vertical axis. See, it's labeled. The x-axis is horizontal. See, it's labeled. You find -2 on the y-axis. So you start at 0, you go -1, -2, and you draw that point, right? That's the y-intercept. Then you use the slope, which is +3, represented by the variable m, and you convert it to a fraction, right? 3/1, 3, 3/1, 3, 3/1. The top number tells you your vertical movement is positive, so you're going up. The bottom number tells you your horizontal movement, that's positive, so you're going to the right. So the slope is a set of instructions. The slope is not a point. Some people confuse that. They looking for 3 on the y-axis. No, you ain't doing that. The slope tells you where to go. So you start here at your y-intercept, and you go up 3 points. You go to the right, and then to the right 1 point, or to the right 1 point, and then up 3 points. It don't make a difference. You're going to end up at the same point anyway. But I typically go in order. I go vertical, then I go horizontal. So I go 1, 2, 3 over 1. Boom. That's my second point. Now, some teachers want you to do at least 3 points. You can if you want to. You know, not really totally necessary, but I mean, it's good. It's a good practice, I guess. I'm not knocking it. But I'm cool with 2 points because you're going to get the same line anyway. So we do this, right? We draw a line through these 2 points. Put the arrowheads at the ends. Make sure you put the arrowheads at the ends because it's not a line segment, it's a line. Line's going forever in both directions. All right. Excuse me. So that's how you draw that line. So that line is drawn, right? Now we're going to draw this line. And then where these two lines intersect, the x coordinate of the point where they intersect is our solution, the x value. So y equals -8. This is a horizontal line. Whenever you have y equal to a number, that means you have a horizontal line because the slope is 0, right? Because there's no x term. The only way the x term could be gone or gotten rid of was if the slope had been 0. Like up here, the slope was 3. 3 times x is just 3x. But if the slope was 0, that would have been 0 times x. And what happens when you multiply anything by 0? The product is 0. So the x term would be gone. It would just be 0. Right? That's what happened down here. Right? We don't know it. We didn't see it happen, but we know this is the result of there being a 0 slope. All right. So that means we got a horizontal line. So we got to find -8, but -8 is our y-intercept, right? But it's just that it's a horizontal line because every point on that line has a y value of -8. Y is always -8. No matter what, it's always going to be -8. And they never going to not be -8. Y is always going to be -8. So I find -8. I go here. I go -1, 2, 3, 4, 5, 6, 7, 8. And that's that. And I draw a horizontal line. Yeah, draw a horizontal line. Straight across like this. Put the arrowheads over there. And this is our intersection point. This is our intersection point. So that looks like -1. Looks like it lines up with -1. Something ain't right though. Maybe it's my graph is off. Y equals -8. Did I do something wrong? Huh. Because if my x is negative, oh, you know what? Yeah, my graph is off. This should be -2. Yeah, this should be slanted. So this is okay. This is what's going on here, right? Looking at this graph, this looks like it lines up with -1, right? And it does, but actually, yeah. See, the answer is -2, right? It's actually -2. My graph is off, right? My spacing is not perfect. My spacing is not perfect. And since my spacing is not perfect, that's why my lines are off, my points are off, and my graph is off. This line should be slanted more this way. It should be slanted more. Because look, if x was -1, this would not be true. Because 3 times -1 is -3. -3 minus 2 is -5. -5 is not the same thing as -8. But what if x is -2? If x is -2, you got 3 times -2, which is -6. -6 minus 2 is -8, right? So the graph is off, but yeah, the graph is off, but you know what I'm saying? Yeah, this is where the point should be, because this line should be slanted more. You know, that's all. Matter of fact, watch what I do. Watch me work real quick. I'm about to fix this real quick. Excuse me. My y-intercept was -2. That's still cool. You go up 1, 2, 3, and over 1. I said I'm gonna go over a little bit more, and I'm gonna draw my line through these 2 points. Oh, what do you know? What do you know? Now when I draw it, look at that. Why was I off the first time? But you know, we make mistakes and then we fix them. We fix the mistakes. That's the intersection point between this line and this line, right? That's the solution. Where they intersect is the solution, right? It's good for us to just know how to do stuff, just know how to do algebra. And if we make a mistake, we fix it. It's cool, all right? So make sure you practice the intersection method. Make sure you know how to solve equations, linear equations using traditional algebraic techniques, but also know how to solve them by using graphing, which basically is just the reverse of solving a system of equations. Because you might be given a system of equations where you have 2 equations, y equals 3x minus 2 and y equals -8. And then what you would do is, in order to solve that algebraically, you would combine those 2 expressions into one equation, those 2 equations into one, yielding you this, right? Except in this problem, you're given the equation first, right? You're given the combined equation first, and then you got to break it up into 2 separate equations, this one and this one up here. And then you graph each line, and then you find out where they intersect. So it's just a way to develop like algebraic fluency. Algebraic fluency. It's a good way to develop algebraic fluency. All right. So that's about it. I'm out. I see you on the next video. Peace.